And good afternoon. Welcome to the channel if it's your first time here. All right. Today I want to talk a little bit about data storage. I've been watching some YouTube channels and hearing a lot of talk about home servers, NAS, how to protect your data. And I just thought I'd, maybe touch on a few topics here that are maybe of interest, put my 2 cents worth in. It's there's a lot of different opinions out there, and I guess everyone's entitled to them. But let me just tell you a little bit about mine. First off, who am I? I'm a multidiscipline data center engineer with over 30 years experience. Okay, I've worked in Fortune 500 companies as a lead or senior engineer in data centers. I started out with mainframes. I moved over to servers, Windows, Unix, such as Sun Solaris back in the day. Now Linux. Worked with networking, storage, you name it. I've done a little bit of everything. Okay, and I'm still learning. Okay, I'm not going to say I know everything, but I've been around the block a few times. So for what it's worth, this is my opinion on things. Okay, a lot of conversations out there, and the first thing we want to talk about with storage, we want to talk about uptime. Okay, there's 365 days in the year, and people start giving numbers as percentiles. 99% uptime, four nines, five nines. Well, what does that mean? Okay, there's 8,760 hours in a year. Okay, now if you want 99% data availability when you're designing a solution, that means 87.6 hours, over 3.5 days during a 12-month period. You cannot access your data. The system's down. Okay, 99.9% uptime means that for a full 8 hours every year, your data's inaccessible. Okay, and you hear about five nines, 99.999%. That's about 5 minutes of downtime a year maximum. Okay, and when it comes to system reliability, time is money. Okay, when you're starting to talk five nines of availability, you're really getting into some serious dollars. But that's not where we're at for most people. So let's keep it kind of real here and talk about what really matters to most people. So just looking at some basic terms, business continuity, okay? Just keeping your systems running after a failure. Now, this is a small failure, relatively speaking, okay? Maybe you lost a hard drive, maybe you lost a server. The systems keep running. Your backup, your back end business, okay? Disaster recovery, however, is restoring a system after the loss of something much bigger. You lost a data center, you lost some key servers, you lost something big. Perhaps a software problem or something like a ransomware attack. You get a bigger problem on your hands. Okay. With that, we have what's called a service level agreement. So when we talk service level agreement, these are the expectations you have for having things up and running. Now, for a home user, that may not be anything exotic at all. You got to go to work. You can leave it down all day. Don't worry about it. Okay. But if you're running a business, you may have to, shut the business down if you don't have your systems. If you're a web based business and your customer facing website is down, you're losing money. Okay. Part of that is also in the service level agreement we're going to talk about is getting the systems back online and what that means. Okay. Okay. Your recovery solution. Now, a lot of times you're going to hear this. People call this a backup solution. Backups are only part of a recovery solution. Okay. You can back up data all day long. You can have up to the minute backups, but if it takes you 2 weeks to restore your systems from that backup solution, that may not be an answer. And so that's something, we really want to think about as part of this process, okay? All right, more terms. RAID, redundant array of inexpensive disks. Pay attention to the first word there, redundant. I was recently watching a video where someone was talking about hardware RAID was dead. Well, I guess for a home server or somebody who's building things out of, eBay parts, maybe you don't need to have any form of hardware RAID, but that's maybe a little misleading, okay? Because if a system needs a boot drive and your boot drive fails, software RAID isn't going to do you any good. Okay, so again, that's just something to think about. Okay, so then we're going to talk about what's next in our terms here. Backup is a full point in time copy of a system's data, including configuration, independent of the original. Okay, so that means that wherever your backup is, if the original data, if the original system is completely gone, I use the smoking crater analogy. You come into work one morning and you pull into the parking lot and your entire building is gone and there's just a smoking crater there. You've got nothing to work with. So your backup should survive that kind of event, okay? Then we talk about replication. Now, this is where we copy a system's data in either real time or near real time, okay? So that means you've got your primary system is generating data, things are being stored onto disk, that information is being transmitted across data communication, across the internet to another storage facility, okay, another location, okay? Now, that is still not a backup. We'll talk about that in a second. A snapshot, then we also have our next term, a point-in-time copy of a system's data that depends on the original, okay? So a lot of NAS solutions, a lot of storage arrays could take snapshots, but they are still dependent on the original, okay? So they make a copy of changes as they're being made, and then they can present those to another system, another like a server, in a state where it looks like they're a point-in-time copy of the data, okay? But if you lose the original, database, if you lose the original file, a snapshot doesn't do you any good, okay? RAID, replication, and snapshots are not backups, okay? They're useful tools, they're good to have, you can do a lot with them, but they're not backups, okay? So what's important is understanding the need. What's appropriate for a home server may not be right for a business. While your copies of all your DVDs, all your videos at your fingertips so that you can watch them from the convenience of your living room without having to get up and put discs in your DVD player is certainly a nice thing to have. It may not justify spending thousands of dollars to build a fully redundant solution, that can survive, major disasters and so forth. You have to understand what the impact of the outage is. Now, for what makes sense for a home user, you can watch a YouTube video and someone will show you how to take a 10-year-old server off of eBay and turn it into a multi-terabyte home storage server, and that may be just fine. But you may not want to carry that into the business world, right? So just because you can do that for a home solution doesn't mean that as you're starting out and needing something for your business that you want to go down that same route, okay? With that, you have to have real expectations for recovery. If you've got a solution that's going to take hours or possibly even days to get back up and running, again, that may be okay for a home user, but it may not work for a business solution. You could be losing money, losing customers. You just don't want that kind of experience. And again, in these expectations, most of the time, if you can predict the disaster, it should not have been a disaster, right? So if you're building a system and you can look at it and say, well, if my boot device fails, I'm going to lose access to my data until I can get a new boot device and I can rebuild the system from scratch and recover it all. Okay, it's not a disaster if you could predict it. Okay, it's just carelessness. Okay, poor planning. And with that, backup plans are easy. Backup to the cloud, backup to a remote location. That's all great, but tested recovery plans are hard. Okay, so when you find out it's going to take you 3 or 4 days to recover your data from the cloud, that may mean that solution is not good enough for what you need. Okay, an untested recovery plan is it's essentially wishful thinking. Okay, you don't have something that you can have faith in. It could go sideways a dozen different ways, right? So, let's start at home here, okay? Most of your applications are not critical. Maybe Exceptions might be a home surveillance system, where it's important that you maintain, monitoring your property. You have a real risk of financial or safety or security if your surveillance system goes down and you're not recording the video you need to. Okay, but for those kind of solutions, sometimes redundancy at the device level may be your best solution, right? You could have, for example, two separate storage solutions that are easy to switch between, rather than trying to build a high availability network storage device that covers all angles. Because, for example, you could build a 5 disk RAID with two parity drives and all the other nice to haves, but if the breaker trips and knocks the system offline, you still lost your functionality. So sometimes you have to look at, what are the points of failure, what can go wrong, okay? And so sometimes you want to move up the chain a little bit and put your redundancy at the higher level. And with that, spend money on solid backups before you worry about fancy RAID solutions. Again, RAID is not a backup. Now, if I've got all of my data safe and secure, off-site, in a reliable location that's geographically separate from where my primary source is, the odds are I'm not going to experience a full data loss. I've got the data somewhere else. I can get to it. It's safe. It's protected. It was well thought out. I'm good to go. Okay. The next item is map your requirements to the hardware, right? Video recording, you may need high reliability, but it doesn't have to be cutting edge performance. So a group of disks that are relatively low performance, low RPM, but very large might be your best solution there, right? They're less expensive per terabyte, and they'll do the job. Add to that a small pool of fast drives for like a home laboratory, or we're running virtual machines or something like that, and you've got a better combination than trying to build like an all than trying to build an all solid state SSD solution with the same amount of storage. Mix and match as you need. Match things up so that your solution cost and performance match the requirements. All right. All right. For business needs, that things might be a little different. Based on what I've seen, I've been watching some YouTube videos, and most of the so-called influencers giving advice, have never managed a 200 node storage area network. Okay, so what does that mean? 200 mission critical servers attached to enterprise class storage arrays in the petabyte size. Okay, these are big environments. I've done that. Okay, and when I hear people making some of the comments I have, I think, okay, you're really not qualifying this to say this is good for a home lab. These are people, some of which are advertising themselves as a business and someone to call to you pay them money to set up your environment. And a lot of what I'm seeing is really questionable in my mind. You don't always need an enterprise class solution, don't get me wrong, but you should understand what that means. Okay, you always got to remember Murphy's Law, and Murphy was a raving optimist. And anything that can go wrong will go wrong at the worst possible time. And time is money, and downtime can be expensive. So you've got to be careful with your business. Be careful what some of these claims that people are making. Some of them are just bad advice. Okay, and just a few nits to pick here. Bad habits start early, and sometimes they're really hard to break, right? So when you see someone giving you advice on how to build a storage solution, and they're taking solid state 2.5-inch drives and just stacking them unsecured in the top drive bay of a server just to kind of get by, when you can buy a inexpensive disk caddy for $10 off of Amazon. What kind of professionalism is that? What they're doing is showing you that they're willing to show you them taking shortcuts without even maybe realizing that you don't realize where all the shortcuts are being taken. You might be seeing things that are, just bad advice. I saw another one where someone was using an older workstation board to build a NAS, and they were commenting that the system was having post power on self test errors. Right. I looked at the self test error and was complaining that one of the RAM sims, one of the RAM chips was bad. Okay, and didn't even pick up on that. At the end of the video, he mentioned that reseeing the RAM fixed the problem. But again, these are things that you should, why are you including those in your video? If you understand what you're doing, you should be correcting those and cleaning those up before you think you're ready. Okay. The other thing is, be skeptical when something outside of an so-called influencer's niche is dead. Okay, when they start talking about, well, this is dead, you don't need these anymore. Maybe what they're really telling you is that my sponsors don't sell those things. Okay, or I don't understand them, and a lot of times it really boils down to I don't know what I'm talking about. Okay, so you know, give things like that up. Again, my this is going back to someone was talking about how hardware RAID was dead. Well, tell that to the storage vendors that are selling, multi-million dollar disk arrays built on hardware RAID. It's not dead. Oh, and by the way, those are arrays that are backed with solid state disk that is faster than anything going on in these videos. So these are not, small systems that are being used for, home use. These are, hundreds of thousands of IOPS going on. I watched one recently where all the person making the claims about RAID, all he could talk about was what the IOP rate on solid state disk was. Well, RAID is not about IOPS. As a matter of fact, RAID can it's well known that RAID can cause problems with IOPS. RAID's job is to provide redundancy, high availability to deal with failure, not provide ultimate performance. So again, beat it to death. I'll leave it alone there. Another thing to think about, top-end products from 3 generations ago may still be better than the current generation budget systems, right? So again, you see a lot of these YouTube videos are showing you how these new solutions are, the best, and this is, this video is being created in 2025, the best solutions for 2025. Well, frankly, the best solutions from 2023 may still be great solutions. Last year's model is quite possibly just fine. Nothing wrong with them, and don't lose sight of things for people pushing their sponsors' latest and greatest. Okay, and again, the final one is if it's not sponsored, it could be someone just fishing for sponsors. Little skepticism is a good thing. When I see someone tell me that this video is not sponsored and they're showing me $10,000 worth of products laying on a table, maybe not this one, but something was. Okay, money's coming from somewhere. All right. All right. Well, I hope that helps. We'll move on to something just a little bit of examples here to talk about some of the things to look at when you are building a RAID solution or a storage server. What I'm going to here. This is just a little virtual machine I've got running over on the side. It's running Windows 2022 evaluation. Just downloaded it off the internet, spun it up. It's just I'm talking about principles here. Windows may not be the solution you want to go with, but it's a nice graphical user interface, and I think it's easy to use it to explain things, right? So, in this example, I have 3 10 gig disk drives. Obviously, this is just for doing the demonstration, but it's just nice and easy to show you the technology without having to build a big set of physical disks. All right. So, what we can do with these, we can create different types of RAID arrays. And one type of RAID array that you might hear is RAID 0, which is basically taking multiple disks and making them look like one large disk to the operating system, right? So we take we take our, in this case, it's going to take all three of our drives. We're going to add them together. We're going to go next. These three 10 gig drives, and we get what looks like to the operating system a 30 gig drive. Okay? Now, if you're building a home storage solution and you don't want to build an expensive RAID solution, avoid the temptation to use this, okay? So you've got three times the storage space in one disk, but if any one of these three disks fail, you lose the whole set of data. So that does not do you a lot of good, okay? Here we see our drives are all spun up, they're all ready to go, and we see here we've got a 30 gig E drive created from our three 10 gig drives, okay? So here we are, and there's our E drive. All right, so what else can we do here? Let's take this one offline. All right. See, we took one drive offline, we lost it. All the rest of our drives are now gone as well. We've lost the data from this dynamic disk. Okay. So I can turn this, bring this back online, and everything comes back healthy. But if this was a physical disk and we lost it, we couldn't get it back, that data's gone. All right. So we're going to delete this volume now. All right, so we're back to where we started. So let's start and create a mirrored volume. All right, so we're going to add just one of our three disks. Okay, we're going to assign it, and we're going to go ahead and let it do its thing. Now, a mirrored disk means that everything written to one disk is written to the other disk, which means that half your storage is lost. However, this is in just general terms, your best performing and just a generally good way to protect something like a boot drive or some other small drive where you have a small set of data that needs protecting, okay? So now we look up here and we have our mirror, and we see it's only 10 gigs. We've got two drives, we're going to only have 10 gigs. Now, down here, this drive, we can't do anything with it, all right? So it can be used for something else, but it can't be used as part of the mirror. So we just have to leave it at that, all right? All right, so we're going to remove the mirror. We see we're back down to a single drive. Okay, let's go ahead and delete the volume. All right. Now, what's our third choice here? Okay, or an additional choice. Okay, we're going to create a RAID 5 volume. Now, RAID 5 means that, get this going here, we're presented with basically, we lose one drive for what's called parity data. Now, a lot of people will say that that's a parity disk, but that's incorrect. In RAID 5, the parity block is generated for each bit of data, but that block is moved across all three drives for each what's called a stripe, okay? So you'll have parity blocks here, here, and here, okay, on all three disks. So you don't depend on any one disk, okay, and they're balanced. So what happens in other, like RAID 4, you do have a parity disk, and you can get I/O imbalance where you get a bottleneck on your parity disk, your parity drive. So RAID 5 takes care of some of that. It has other costs where it's a but it's a good compromise, right? So among the multi-disk striped solutions, it's very popular because of its versatility and its performance. Now, the nice thing about RAID 5 is you can increase the number of drives. So I'm using three disks here, which is the minimum. But depending on what your system needs are, you can have five, six, maybe even 10. Okay. Now, there's reasons you don't want to go too large on a solution like this. Too many drives. There's consequences to failure and rebuild times. If you lose a drive and you have to rebuild the array, which happens while the array is still available, while the data is still available. So yeah, it's a balance, but this is just to give you a general idea, right? So this is the RAID 5, and again, it will give us 2/3 because we have three. We take out one, so we have about 20 gigs in our RAID 5 drive. Okay, so just a quick demonstration, just to explain that what the different types of solution are, and just right now I'm just noticing we're getting a resync going on. So it's rebuilding its parity information, its data protection information after being created. So that's part of the process I just mentioned. On the longer that takes, until you go healthy, you you could be vulnerable to a second drive failure. So that's why you sometimes want to limit the number of disks in a RAID 5. But here's our array. Okay. All right. Well, I hope that makes sense. I know this is kind of a little ad hoc video and it's not super fancy, but I just hope it helps you get your head around it all. Thank you much. Bye.